Good morning. So this presentation we will see about the carbohydrates introduction. This is for the fourth semester B.Pharm students under the fifth unit of your syllabus, the carbohydrates. After seeing the introduction, we will see about some of the drugs which comes under this carbohydrates. So, about carbohydrates, you might have studied in your previous semesters, and you are very well versed with the term carbohydrates and the aspects regarding the carbohydrates. So, when you just see the carbohydrates, formerly they were defined as the group of compounds which composes of carbon, hydrogen, and oxygen. And the later two elements, that is hydrogen and oxygen, they are in the same proportion as in that of water, and they are expressed by the formula CnH2O in brackets N. The word carbohydrates was traced from the German word called as Kohlenhydrates, which means carbohydrates in English. And when you just see the former definition of carbohydrates, which consists of the three elements, carbon, hydrogen, and oxygen, and having the formula of CnH2O bracket N, it is not valid and it was misleading when we see few compounds like acetic acid and lactic acid. The acetic acid molecular formula C2H4O2 and the molecular formula of lactic acid C3H6O3 also same, but they are not under the class of carbohydrates. So the former definition was misleading. So later, to accommodate a wide variety of compounds and to remove that misleading, the carbohydrates are defined as the organic compounds consisting of polyhydroxyaldehydes or ketones joined together by 1,4 or 1,6 linkage, which on hydrolysis is the same. So when you just take this definition, it has the polyhydroxyaldehyde or a ketone, and they are joined together by 1,4 or 1,6 linkage, and on hydrolysis they are going to give the same. That means the polyhydroxyaldehydes or ketones. When you just see the occurrence of carbohydrates, they are much abundantly present in plants rather than animals. These carbohydrates are widely distributed in plants and also to some extent in animals, and they are usually present in the green plants by the process of photosynthesis. You know very well, starch is produced by a process called photosynthesis. And this process occurs with the presence of chlorophyll, a pigment in the plant. It absorbs carbon dioxide from the atmosphere and takes up the water from the ground. In presence of sunlight, it is converted into starch and the oxygen is released. You know very well about this. And next, we'll see about the carbohydrates classification. When you just take the carbohydrates, they are divided into two categories. One is the simple sugars are called as saccharides, and the next class is called as your polysaccharides. They are called as your non-saccharides. And this simple sugars, they are nothing but they are the uh, substances which are considered to be the lower molecules of carbohydrates. They are crystalline in nature and they are freely soluble in water and they have sweet taste. And what are the examples? Or again, further, the simple sugars are classified into monosaccharides and some of the oligosaccharides. In oligosaccharides, you have a few examples of your disaccharide and some trisaccharides and tetrasaccharides. And when you just see the monosaccharides, they are further classified into 6 different types based on the number of carbon atoms it contains. That we will see in detail in the coming slides. And oligosaccharides means they comprises of the carbohydrate class which contains more than 2 monosaccharide units. And this oligosaccharide, it may have the disaccharide in its class, that is the lower polysaccharides, like up to 4 saccharide units. They are coming under the oligosaccharides. And if the number of monosaccharide units are more than 4 or 5, they are called as polysaccharides. They are completely non-sugar in nature. In case of oligosaccharides, some of the disaccharides will come under the simple sugars. Next, we will see about the monosaccharides. They are the simplest form or the simplest classification of our carbohydrates. They are the basic unit of carbohydrate. And these are the sugars or carbohydrates which cannot be further hydrolyzed into simple sugars or simpler molecules. Simply, these sugars are formed only by the polyhydroxyaldehyde or ketonic group. And the most abundantly present monosaccharides are D-glucose called as dextrose, and apart from that you have your fructose example. And when you just see the classification of monosaccharides, as I already told you, it is based on the number of carbon atoms present. Like bioses, they contain only 2 carbon atoms. They do not occur freely in nature. The next one is trioses, that is nothing but they contain 3 carbon atoms. They are present in the form of phosphoric esters, that is glyceraldehydes. And next class is tetroses, which contains 4 carbon atom in its molecule. Example is erythrose and threose. This erythrose is present in hemoglobin. And next you have your pentoses. They are very much commonly present in plants where uh, they are the hydrolyzed products or hydrolysis of uh, polysaccharides and hemicellulose or mucilage or gums happens. The products comes out are your pentoses. That means they are usually present in the polysaccharides like hemicellulose, mucilage and gums. So when you hydrolyze these products, they give rise to the pentoses. The examples of pentoses are ribose, arabinose, xylose, etc. And hexoses, they contain 6 carbon atoms and they are much abundantly available in the plant kingdom. And very commonly used sugars. And these hexoses further divided into 2 categories based on the functional group present. Aldoses, which contains your aldehyde, and ketosis, which contains your ketone. The example for aldoses are the glucose, mannose, and galactose, whereas ketosis examples are fructose and sorbose. And these hexoses are obtained by hydrolysis of polysaccharides like starch, inulin, etc. And again, based on the presence of these things, they may be the polysaccharides may be further classified into homopolysaccharide and heteropolysaccharide. I'll come a little later. And next is the heptosis, which contains 7 carbon atoms. It is the last class of your monosaccharide. And usually they are important and they play their role in photosynthesis of plant and glucose metabolism in the animals. Examples are glucoheptose or manoheptose. So that is about the classification of your monosaccharides. Here you can see the triglyceride, that is the trioses, glyceraldehyde, triose example, erythrose example of tetrose, and ribose example of pentose, and hexose example you can see the aldehyde as glucose and fructose as a ketone or ketosis, and heptosis you can see the structure of your glucoheptose. And next to the monosaccharides, the next classification is a disaccharide, which on hydrolysis yields 2 molecules of monosaccharides. Example, sucrose, you can say when you just hydrolyze your sucrose, you get glucose and fructose. They are the 2 different monosaccharide you get. And maltose is another example which is present in the malt extract, which has the 2 molecules of glucose. And next classification is your trisaccharide on hydrolysis, which gives you 3 molecules of monosaccharides. Example, raffinose. On hydrolysis, it yields glucose, fructose, and galactose. And rhamnose, which gives 2 molecules of rhamnose and 1 galactose unit. And next is the tetrasaccharides, which has the 4 molecules of monosaccharide units. Example is stachyose. On hydrolysis gives you glucose, fructose, galactose. That is 2 molecules of galactose it gives. And next you can see the polysaccharides, which has n number of your monosaccharide units. On hydrolysis, it will produce indefinite number of monosaccharide units, which are called as glycans. The commonly occurring polysaccharides and which is of highly biological value is your starch, which is present in the plant, synthesized by them. Glycogen, it is an animal starch. It is the storage form of glucose in the liver and in the other parts of the cells in the animal, and also cellulose and inulin. When you just see the starch, it is joined by n number of glucose units. The linkage is between alpha 1,4 or alpha 1,6. Whereas in case of cellulose, this is also made up of only glucose units, n number of glucose units are joined together, but the linkage is by beta 1,4 linkage. And another important class of this polysaccharide, we can say that homopolysaccharide and heteropolysaccharide. That is nothing but homopolysaccharide means it consists of same monosaccharide units. Hetero means it consists of the different monosaccharides in their structure. And apart from this saccharides, the important derivatives or the class of carbohydrates, which comprises our gums and mucilages too. When you say the gums, already we know that in that the pentoses are present in gums and mucilages. These gums are nothing but they are the calcium, potassium, and magnesium salts of complex polysaccharide units, that is called as polyuronides. On prolonged boiling with dilute acids, that is on hydrolysis, they give the sugars and uronic acids. And the mucilages, if you see, they are the sulfuric acid esters. They are the sulfonated esters of your polyuronic acids. So that is why when you just do the chemical test in your practical aspect, you will be doing chemical test for acacia, dragakant, and agar. When you do that, you will be finding the difference of gums and mucilage by a chemical test, that is the treatment with barium chloride after hydrolysis. In case of your mucilage, it gives a white precipitate because of the liberation of sulfuric acid on hydrolysis. Why the sulfuric acid is liberated? They are the esters of sulfuric acid. They are the esters of sulfuric acid and polyuronic acids. So that is why when you hydrolyze the mucilage, it will give out the sulfuric acid. So when you treat with the barium chloride, the hydrolyzed solution, it will give you a white precipitate. Whereas in case of gums, they are not the sulfuric acid esters, they are the salt of calcium, potassium, magnesium. So there is no sulfate ion to react with the barium chloride. So which in turn you are not going to get a white precipitate when the hydrolyzed solution is treated with barium chloride. Okay, so that is the test. You can identify or you can differentiate the gums and mucilages. When you are doing your practicals, you will be getting a clear-cut idea about this. And next is the identification test for the carbohydrates. This carbohydrates can be identified generally by Molish test. That is, the sample is treated with the Molish reagent followed by the addition of concentrated sulfuric acid. They give a purple colored ring at the junction of two liquids. I think you might have studied about the mechanism of formation of the percural ring at the junction of two liquids in your biochemistry as well as your organic chemistry. And next is the test for reducing sugars. Here, the solution of carbohydrate is treated with equal quantity of fillings A and B solution. And after that, it is just warmed to get the reddish orange or brick red precipitate, which shows the presence of reducing sugar. And next is the Benedict's test, which shows the presence of reducing monosaccharide. Here you can identify the reducing sugar as a monosaccharide or a disaccharide. So if you take example of your sucrose, it is a sugar, but it is not a reducing sugar. Whereas if you take your mannose, they are the disaccharide, but they are reducing in nature. So to identify that, Benedict's test can be done. The sample is treated with Benedict's solution and it is heated. You get a brick red precipitate. And next one is the test for pentosis. The sample solution is taken and it is treated with hydrochloric acid and chloroglucinol, which gives a red color due to the presence of pentosis. And next one is your Selivanoff's test. The sample solution is treated with Selivanoff's reagent and warmed. You'll get a rose color, which is due to the presence of ketosis, that is fructose. Especially this can be identified in the honey or sucrose. On long heating, with sucrose solution, you get a rose color. This Selivenops is nothing but resorcinol in hydrochloric acid. And next one is your ozone test. We are not going to perform ozone test as our pharmacognosy is concerned. You might have done in your biochemistry. That is nothing but the sugars are differentiated by the different formation of crystals. That is the ozone derivative formation. The sample solution is heated with phenyl hydrogen hydrochloride and sodium acetate in presence of acetic acid. You'll get the yellow colored crystals which will be observed under the microscope, which gives the different forms of orientation by which you can differentiate the different types of the sugars. This you might have studied in detail in your biochemistry. But as our pharmacognosy point of view, this is not much of importance. The other test we can perform. So these are all the identification tests for the carbohydrates. So as you know, the solubility of your carbohydrates, they are easily soluble in water. That is, the sugars, the simple sugars are freely soluble, and the polysaccharides in the boiling water, they are soluble and insoluble in the organic solvents. Okay. So that is about the introductory part of your carbohydrates. And next we will go to the pharmacognosy of drugs containing your carbohydrates. So under your syllabus, you need to study about the 4 drugs, that is acacia, agar, tragacan and honey. These are the 4 drugs you have to study the whole pharmacognosy. So under that, first we are going to see about the agar. So for your easy remembrance, you can make the tabular column like this. You can add up all the drugs together, so that which will be helpful for you during the practicals, or as well as during your theory also, for as well as for the viva point of view. You can make a tabular column with the synonym, biological source and family, chemical constituents, uses, substitutes and adulterants. Synonym for the agar, it is otherwise called as agar-agar or vegetable gelatin. The biological source, only the name of the species I had given here, that is Gelidium amansi, belonging to the family Gelidiaceae. For your easy remembrance, I had given like this. And the chemical constituents, agarose, which is responsible for its gel strength, and agaropectin, which is responsible for its viscosity. It is used as the laxative, emulsifying agent, suspending agent, as well as in the preparation of jellies, suppositories and pessaries, and it is also used in the media preparations. It is otherwise called as a vegetable gelatin. The substituent and adulterants for agar is your Danish agar and Indian agar. Okay. So now we will see the detailed pharmacognosy about agar. So agar, morphologically, it is an unorganized drug. It is the extract, dried extract, and chemically it comes under carbohydrates, and it is used as a laxative as well as the pharmaceutical aid. The synonym, it is otherwise called as agar-agar, Japanese isinglass, and also it is called as vegetable gelatin. The botanical source of agar, it consists of the dried gelatinous substance obtained by extraction with water from Gelidium amansi, or Other species of red algae like Gracilaria and Pterocladia species belonging to the family Gelidiaceae. That is Gelidium and Pterocladia belonging to Gelidiaceae family, whereas Gracilaria species belonging to the Gracilariaceae family. And next, if you come to the geographical source, Japan was the only country which was producing the agar before World War II. But now agar is produced in several countries like Australia, New Zealand, Korea, South Africa, United States, Chile, Spain, Portugal, and in some areas of India too. And when you just see the collection and production of agar, this red algae, they are grown in rocks in the shallow water as well as in the oceans. In the oceans, the agar, the red algae, is allowed to grow on the bamboo sticks which are spread on the surface of the ocean. Usually, the collection of this algae is done in summer, that is in the month of May and also in October. The bamboo sticks are taken out from the ocean and the seaweeds are stripped off. And it is dried. The sticks are beaten and shaken to remove the sand and shell attached to them. And the entire material was taken to the shores and washed well with water, and it is dried under the sunlight where bleaching also takes place. During drying, the sprinkling of water and rotating them periodically is essential. After drying, the agar is then boiled with water or dilute acidified water, which is acidified by using acetic acid or sulfuric acid. Usually, one part of agar is boiled with 20 to 50 parts of water, which is acidified by using acetic acid or sulfuric acid. And the hot extract is subjected to filtration, that may be of course a fine filtration using a cloth to remove the large and small impurities present in them. Then the filtered extract is transferred to the wooden troughs and it is allowed for cooling where it forms a jelly-like mass. And the mass obtained is passed through the screw press to obtain the strips of agar. If you want to obtain the strips or the ribbons. These strips, they contain water, and to remove the water present in them, the agar strips are placed in the open air. So here the Japanese climate benefits the drying of this agar. That is, freezing and thawing effect is brought with the help of the Japanese climate. So what is that freezing and thawing effect? During this season, this Japan will have a warm day and the nights are very cold and the temperature will go less than 0 degrees. So as a result of this climate, the water present in the strips are converted to ice at the night, which is called as freezing. And during the daytime, it is a very warm day, so it is reconverted to water and the excess of water present in them are removed by evaporation. So the strips are again and again subjected to this freezing and thawing condition, and later it is dried on the sunlight. Okay, so that is how the agar is extracted from the red algae, that is the seaweed, and then it is processed and dried, packed and sent to the market. And next, when you see the morphological characters of agar, the color, it is somewhat yellowish white to gray in color, or sometimes it is colorless with a slight odor, or sometimes odorless, having the mucilaginous taste. And usually they are available in the form of strips, flakes, or coarse powder. When you just see the size of the strips, it is around 60 centimeters in length and 4 millimeters in width, whereas the sheets are 50 to 60 centimeters long and 10 to 15 centimeters wide. When you just come to the solubility of the agar, it is usually insoluble in water and cold water. Sorry, insoluble in organic solvents and cold water, but soluble in the hot water. And when you just cool the soluble agar in hot water, it forms a stiff gel. So that is about the morphological characters. And next you come to the chemical constituents. This agar consists of a complex heterosaccharide, and it contains two polysaccharide units called as agarose and agaropectin. This agarose, it is a neutral galactose polymer, and it is responsible for the gelling property of agar. This agarose consists of D-galactose and L-galactose unit. Whereas the structure of agaropectin is not completely known, and it is believed that it consists of the sulfonated polysaccharides in which galactose and uronic acid are esterified with sulfuric acid. And this agaropectin is responsible for the viscosity of agar solution. That is why on the hydrolysis, which gives the sulfuric acid, it is the polyuronic acid, which are esterified with sulfuric acid, they are broken down and gives out sulfuric acid, which gives positive test with barium chloride. And next, chemical test. So agar being a carbohydrate gives the positive test with Molish reagent, and the agar solution after hydrolysis, I already told you, with barium chloride it gives the white precipitate of barium sulfate, which is due to the presence of sulfate ions after hydrolysis. So this is the test differentiated from the other gums, that is acacia gum, tragacanth, and also from starch. And the hydrolyzed solution, when you treat it with Felling's reagent and Benedict's reagent, which gives the reddish orange precipitate and brick red precipitate respectively. And to the agar powder, if you add a few drops of ruthenium red solution, you get, or the particles acquire pink color, which is due to the presence of mucilage. This will not happen in case of gums like your acacia and tragacanth. When agar is warmed with a solution of potassium hydroxide, a canary yellow color is formed. And when you just take agar and boil in water and you cool it, you get a stiff gel. When agar solution is treated with 10 by 20 iodine, deep crimson to brown color is obtained, which is distinction from acacia and tragacanth. And to the agar solution, if you add tannic acid, there will not be any precipitation indicating the absence of gelatin. These are all the negative tests, iron test and tannic acid test. And also another test along with the perchloride. It's not going to give you any blue or green precipitate, which tells the absence of your tannins. So that is about the chemical test of agar. And next, the uses of agar. It's having a very wide range of uses. Agar is used to treat the chronic constipation because it is a mucilage which absorbs water, and it is used as a laxative. As a pharmaceutical aid, it is used as the suspending agent, as an emulsifier, as a gelling agent for suppositories. You know what do you mean by suspending agent and emulsifying agent? And it is also used as a surgical lubricant and also excipients in the tablet manufacture, also used as a disintegrating agent. And this agar, sometimes it is used in the microencapsulation, and it is also used in some ointment preparations, and it is also used in dental impression mold base along with the other substances. And extensively, this agar gel is used in the preparation of nutrient media for the bacteriological cultures. Usually it is called as a vegetable gelatin because it is used as a substitute for gelatin in making many preparations in the food industry. And also it is used in making photographic emulsions, gel in cosmetics, and as a thickening agent in the food industry, especially in the preparation of confectionaries and dairy products. It is also used for sizing for silk and paper industry. It is used in dyeing industry, in the dyeing and printing of fabrics and textiles, and also it is used as an adhesive. So these are all the wide range of uses of agar. And next, or the last point in the pharmacognosy of agar, is the substitute and adulterants. The common adulterants or substitutes for agar is your gelatin and Danish agar. The presence of gelatin can be detected by the addition of trinitrophenol, that is nothing but the saturated picric acid solution to 1% solution of agar. The solution produces turbidity or precipitation. And this Danish agar, it has an ash value of around 16.5 to 18.5, and it is also obtained from the Rhodofaceae family, and it is indigenous to Denmark coastal region. And this Danish agar has the gel strength which is lesser than agar, that is half of the gel strength of agar, Japanese agar. So that is why, by determining the gel strength of agar, the Danish agar, which is added as an adulterant, can be found out. Okay, so this is how you can check the adulterants. Gelatin by treating with saturated picric acid solution, and Danish agar by checking the ash value as well as the gel strength, because it has only half of the gel strength of Japanese agar. Okay, so here hence the pharmacognosy of agar. So here we shall stop the class. The rest of the drugs we'll see in the next presentation. Thank you.